Bienvenidos, Ushamdi, and welcome CTS230 Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 or the Scaling Networks V6 course, and this morning's video tutorial and solution set is going to be on Packet Tracer Activity 8.3.3.5, where we're now going to build on the previous activity, which was 8.2.2.7, where we did single area OSPF V2, and now we're going to be taking a look at single area OSPF V3. So let's go ahead and dive in here. Hopefully this doesn't crash on us like it did toward the end of the first activity. So as you can see, it looks like we've got a pure IPv6 environment here. And so what can we say when we talk about IPv6? Well, first and foremost, IPv6, and this was the OSPF version 2 RFC I mentioned earlier, 2328. And this is the OSPF for IPv6, or the OSPF V3 RFC, which is 5340, and lots of really good information in these RFCs if you're looking to become a subject matter expert. So let's move back to the activity. And here we are. So let's go ahead and let's sort of kick things off, and this will spur some additional conversation. So we're going to log on to router 1. Now, one of the first things I want to talk about is OSPF V3, or OSPF for IPv6, was literally a complete rewrite of OSPF V2, right? So very little of the OSPF V2 code was able to be, sort of merged over or brought in with OSPF V3. So let's go from user exec to privilege exec and into global config. And let's go ahead and enable IPv6 unicast routing, because remember, if I say IPv6 router OSPF and then the process ID number, which we're going to be using 10 again, if I was to say that right now, we're going to get an error message telling us, hey, IPv6 unicast routing needs to be enabled first, and then you can come back and say router OSPF 10. Now, just like OSPF V2, OSPF V3 requires a router ID. Now, in a pure greenfield, pure IPv6 environment, where we only have IPv6 addressing, you can see here that we get this no router ID syslog message. And here's the facility is OSPF V3. We get the severity level 4 as a warning, and then a mnemonic here telling us, kind of giving us a hint as to why we're getting this message. Why is the warning message coming up? We couldn't pick a router ID, please configure. So we need to manually configure the router ID, and we're going to stick with that same setup we had earlier, which is simply 1.1.1.1 for router 1 and so forth and so on for routers 2 and 3. Now, it wants OSPF. Okay, I'm just making sure we've got everything here. So now we need to enable OSPF on the interfaces. And remember, we're enabling OSPF, the process, right? So kicking off those multicast packets that are going to be flowing out of the interface on which we enable the OSPF process. In this case, we're enabling OSPF for IPv6. So the multicast address will be FFO2::5, and we would see FFO2::6 in the event that we had a DR and a BDR. Because remember, FFO2::5 is the all OSPF router address. So any OSPF router on the segment that has OSPF for IPv6 configured is going to be listening for that multicast address. Remember, that is the idea of multicast. It's one to many. So a router sends out an OSPF hello to FFO2::5 because he's seeking all OSPF speaking routers, or any OSPF speaking router that's out there. And then other routers that are running the OSPF process for IPv6 on an interface are listening to the wire, and they're looking to see, is any traffic for FFO2::5 out there? And if so, then I want to take a look at that. And this is how the adjacency is formed. And so think of it like this, that FFO2::5 hello packet that gets sent out when we configure OSPF on an interface. And this is irrespective of whether it's IPv, OSPF for V, or OSPF version 2 or OSPF version 3, right, for IPv4 and IPv6 respectively. Irrespective of which one we're doing, those hello packets are basically saying, hey, I speak OSPF, here's a multicast packet that only other OSPF speakers would be interested in. Would you like to form an adjacency with me, right? Are you out there? And if so, please respond back. So there is no network command here. And it's not asking for the passive interface command. I thought that was interesting. And let's see here, I also noticed that the score, so no score in this activity. So we'll just go through and configure things, but we're going to go ahead and say passive interface gig 00. We're going to put that in there anyway. And interestingly enough, it's graded only using the connect. Okay, so it's only the connectivity test. I saw that note down there. So no points, it'll be connectivity. So we're set up here, we passive that interface. Now, no network commands, so what do we need to do? Exactly, just like EIGRP for IPv6, we need to go under the specific interfaces, gigabit Ethernet 00, and this is where we say IPv6, OSPF, the process ID, right, just like we did with EIGRP, but we have to add in the area number. Remember, Link State databases were all about the areas here, right? So then do show IP interface brief. It should be serial 000, and this is where the up arrow comes in handy because I can simply pull the up arrow and get that IPv6 OSPF 10 area 0 back and then go into serial 001 and do the same thing. So now, how do I validate? Well, show IPv6 OSPF interfaces, right? And we can see that the protocol, the line protocol is up, and there's my information. I can say show IPv6 OSPF neighbors, right? We don't have anything now because obviously no neighbors. What about a show IPv6 OSPF database? And so then we see that we've got the information in here, and now we take a look and when we did this with OSPF V2 or OSPF for IPv4, we only saw the type 1 LSA. Well, here we see another significant difference, and there are some significant differences between OSPF V2 and V3. And one of those differences we've already seen is that when we go to configure it, there is no network statement. So you can't enable OSPF for IPv6 or OSPF V3. We can't use the network statement. That is something that we could do with OSPF for IPv4. And here's another significant difference, is that, remember, I told you that it was almost a total rewrite, OSPF V3 compared to OSPF V2. And one of the things that changed was we now have 2 additional LSAs. And I know what you're thinking, as if it wasn't enough that we had to deal with the type 1 LSA, the type 2 LSA, the type 3, 4, 5. We briefly mentioned the type 7. Now we've got this type 8 and type 9. And what makes it even more onerous is that here it tells me that, yeah, link type 8. But here it just says intra-area prefix link states. But that's type 9, right? So we now get these 2 additional link type, LSA types for OSPF V3. And again, this one is they're link local in scope, right? And so that's what we need to be aware of, right? It's that link state. And this is link local in scope. Sorry, so this is basically link local in scope, whereas this is I want to say area scope for this guy right here. But again, it's flooded throughout the area. So that is additional LSA information that you're going to see. But from a verification perspective, instead of saying IP, we simply say IPv6. So now let's move on here to router 2. And we're going to pull up the CLI and let's get our configuration done here. We get into global config, IPv6 unicast routing, IPv6 router OSPF 10, right? We need that router ID configured, so we set it to 2.2.2.2, and you'll notice the router ID still takes the form, and this is one of those things, it takes the form of a 32-bit dotted decimal value like an IP address, but it is not an IP address. I'm going to go ahead and passive the gig 00 interface, and then we're going to go into gig 00, IPv6, whoops, OSPF 10 area 0, interface serial 000. When we put that on there, 001. And there's a neighbor adjacency, and so we're good there. So now what does this look like? That link state database though, right? That is one thing that did not change, right? We still have show IPv6 OSPF database. We still have that information, and here is that type 1 LSA, right? And you'll notice the link count is different, right? So link count bits. And that's kind of what this type 8 and type 9 have done. And this is very important, right? A little outside the scope of the CCNA, but very related to what we're talking about, is that the addressing information, right? The link information has been decoupled from the type 1 LSA. So here's the type 1 LSA, and you'll notice that we've got this link count, right? It shows 1. But here's all of the link information down here. So that's what happened, is it took the addressing information, the link addresses out of the type 1 LSA. So if I was to show the router LSA here, right, we see the information, but what do we notice? Where's all the IP addressing? Right? We don't see that information in here. And make sure I said IPv6, and I did. So we don't see that information in here. So that information has been decoupled from the type. It's pulled out of the type 1 LSA, right? And the reason for that has to do with, triggering a run of the SPF algorithm, right? So they wanted to pull that information out of the type 1 LSA, and that's why we don't see it in here, and that's why we see here the type 8 and the type 9. So let's go ahead and finish out here, and we'll pull the CLI up for router 3, and we're going to do much the same thing. Again, good repetition here. Enable for user exec, config T global config mode, IPv6 unicast routing, IPv6 OSPF 10 area 0, and IPv6 router. I knew I forgot something there. IPv6 router OSPF 10, my apologies. And then we get our router ID of 3.3.3.3. I'm going to passive that gig 00 interface, best practice, right? Because nodes out there don't need to be seeing that FFO2::5 or ::6 traffic that may be floating out there. Now we're going to go to interface gig 00, and we're going to say IPv6 OSPF 10 area 0, interface serial 000. Same command, interface serial 001. And the same command, and we should see from loading to full there on serial 000 with router 1, and now we are fully adjacent with both router 1 and router 2. And again, do show IPv6 OSPF database. From an OSPF perspective, there is my link state database. I know everything about everybody. And this is not true when we're talking about distance vector routing protocols. In fact, look at this. Here are the links. So take a look at who the advertising router is. So there are the 2 links for router 3. Here's the single link that I know about from router 1, and actually there's a 3rd link from router 3 here, and then here's the other link I know about from router 2, and these have link local scope, right? So this is router 3, so he knows about the 3 router 3s because those are all local to router 3. I know about a single link between 3 and 1 because, again, the type 8 LSA is the link local. So I don't see the type 8 LSA for the information between router 2 and router 1 because that's not local. That's not a link local piece of information for router 3. And then the same thing here. I see that one link, right, between router 2 and router 3. And then here's the intra-area link information, right? And this is going to be reflecting what? Right, that gigabit 00 link. And in fact, let me see if it gives us, let's see, and let me get out of, let's go here and say show IPv6 OSPF database. And does it give me, or inner area, sorry, I think I want, no, not inner area, I want prefix. I believe it's prefix. Yeah, and so here are those intra-area prefixes, right? And so here is the prefix information. And this is that information that's going to contain, and if I come down here to 1111, and that was 2222, here's 1111, you can see the 2001 DB8 Cafe :1:/64 is right there. Prefix, and there's my information and the metrics. Again, so all of the addressing information has been decoupled, extracted, segregated from the type 1 LSA. And that's a significant difference. And again, done in order to achieve better performance with the SPF. Now, we're being graded here on connectivity. So let's pull the desktop up, get the command window up, and can I ping? Let's do 2001:DB8: Cafe :2:10. And we've got reachability, so we've got points there. And then let's do :3:10. And we've got connectivity there. So very briefly, let's go to check results. And we get the big check. So 3 out of 3, right? A little different from the activities that we've done previously where we typically have some sort of completion percentage. But again, that is OSPF V3 in a single area configuration scenario. Remember, what are the differences that we're talking about? No network statement. Just like EIGRP for IPv6, we've got to go into the interface and make that configuration. Router ID, 32 bits, dotted decimal notation. Looks like an IP address, but is not. It could be in the event that it got it from one of the interfaces that, a loop back maybe that had an IPv4 address, but it is not an IP address. It is the router ID. Some other differences, right? You'll notice I kept saying link. OSPF V2, we said network a lot, right? We used to call it a network. But with OSPF V3, it's link is the key term there. You have authentication just like you do with OSPF V2, but remember with OSPF V3, it is IPv6 that is providing the authentication, right? And more importantly, with OSPF V2, the authentication with MD5, right? That was worked in. That was part of OSPF V2. With OSPF V3, again, just like the type 8 and type 9 LSAs, pulling the addressing information out of the type 1 LSA. With authentication with OSPF V3, it is not part of OSPF V3. It is being provided by IPsec, so it is mutually exclusive from the protocol, right? It's mutually exclusive from the protocol. All right, so this is going to wrap up our activity on Packet Tracer 8.3.3.5, where we took a look at single area OSPF V3, or OSPF for IPv6. All right, thank you so much for watching. Have a great weekend, and I will see you on Tuesday.